Question 1.7 asks us to find the size of the charge on the third point particle. We have called the particles x, y, and z here. We know the distance between the first two particles is r, and between the second two particles, 2r. We are told the charge on the middle particle is small q. We have to use Coulomb's law here, which says the force between two particles is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. We are also told that the net force on the first particle, particle x, is 0. That means that if x is attracted to y, it must be repelled by z by the same magnitude of force, and vice versa, depending on the charges of these 3-point particles. So we need to consider the force between x and y, and between x and z, and the magnitude for each would be the same. For the force between x and y, we can put in small q for the charge on y and r squared in the denominator. And for the force between x and z, we can put in r plus 2r for the distance between x and z. Again, since the net force on x is 0, then the force experienced by x from y is equal but opposite to the force from z. So we can make the two forces equal. Substituting their expressions, we can multiply out the denominator on the right, cancel k, cancel qx, cancel r squared, and we are left with small q equals q of z divided by 9. Rearranging, we get the charge on particle z in terms of small q. It is 9 times small q. So the answer is D.